Galileo Galilei was born in Pisa, Italy on February 15, 1564. Galileo was the first of 6 children. In 1572, his family moved to Florence, where he began studying for priesthood.
He first went to school to become a priest, but in 1583, he changed the University of Pisa to change it to medicine. Throughout his time at the university, Galileo was very indecisive what he wanted to do, but it never ended up mattering because he eventually had to leave the University of Pisa without getting his degree because of financial difficulties with his family.
After Galileo left the university, he continued to study on his own. While on his own, he published The Little Balance, which described the hydrostatic principles of weighing small quantities, and he developed a new science called the study of the strength of materials. Galileo worked on how to back this newfound science. His experiment with cantilever beams best demonstrates his discovery that the braking force on a beam increases as the square of its length. Galileo discovered that as the length of a beam increases, the strength decreases, unless one increases the thickness of the beam at the same rate.
Here the beam, represented by a stick, is too long, therefore too weak to hold the weight. Here the beam is the same length but doubled in thickness. The beam can now support the weight.
Galileo's book, The Little Balance, gave him a teaching job at the University of Pisa in 1509. There he published his manuscript Du Monde on motion, which critiqued Aristotle's teachings on falling objects and motion. Galileo developed an arrogance, and he critiqued Aristotle all the time, which caused him to lose his job at the University of Pisa.
In 1592, Galileo got a job at the University of Padua, teaching geometry, mechanics, and astronomy. In 1604, he published the operations of the geometrical and military compass, showing his experimental skills. Galileo refined his theories on motion and falling objects. He developed the universal law of acceleration, which all objects in the universe obey. To prove this, he climbed to the top of the Leaning Tower of Pisa and dropped 2 balls of different weight. If they landed at the same time, his theory was right. We reenacted this experiment and proved that his theory was correct. After proving Aristotle wrong with this experiment, Galileo began to openly express his support of the Copernican theory, again going against Aristotle.
The Copernican theory is that the Earth and other planets, represented by Calvin, revolve around the Sun, represented by Kelsey. Aristotle and the Church believed that the Sun and other heavenly bodies revolved around the Earth. In 1614, Galileo wrote a letter to his student explaining the Copernican theory and how it did not contradict biblical passages because the Bible was written from an earthly standpoint. Soon after, the Church asked him to never endorse or teach the Copernican theory, and he obeyed this for 7 years because he was a devout Catholic.
In July of 1609, Galileo developed a simple telescope, and in August he showed it to the Venetian merchants. In doing this, Galileo quickly spread his ideas. In March of 1610, he published The Starry Messenger, which said that the moon was not flat and smooth, but it was round and had craters. He discovered that Jupiter had revolving moons, which proved that it did revolve around the Earth. Galileo also found that Venus had phases, proving that it did rotate around the Sun. He also found that Saturn was not perfectly round and that it had rings. In 1612, Galileo published his Discourse on Bodies in Water, discrediting the Aristotelian theory on why objects float on water. He proved that objects floated because of their mass, not their shape. In 1613, Galileo's publication on sunspots disproved Aristotle's doctrine on why the sun was perfect. In 1623, Urban VIII was elected pope. He was a friend of Galileo. He allowed Galileo to continue his work as long as it had nothing to do with the Copernican theory. Of course, Galileo defied this.
In 1632, Galileo wrote the Dialogue Concerning 2 Chief World Systems, the Copernican theory and the Aristotelian theory. The book was a discussion among 3 people, one person who supported the Copernican theory, one person who did not, and one person who was impartial. Galileo tried to say that the book was from an indifferent standpoint, but this quote, "Upon hearing such carping insolence, my zeal could not be contained," clearly shows that he favored the Copernican theory. After the book was published, Galileo was called to Rome. The trial lasted from 1632 until 1633. As a final attempt to break him, the Inquisition threatened Galileo with torture. He finally admitted that he supported the Copernican theory, but he never admitted that his statements were correct. Galileo was convicted of heresy and sentenced to house arrest for life.
Do you know why you have been summoned before the Inquisition?
I imagine you found some cause to be offended by my book.
How could we not be offended by it? It teaches that you are right and the Church is wrong.
I did my best to keep my promise to Pope Urban. I presented both arguments as fairly as I knew how.
If your book was fairly written, why does the Church find it so offensive?
Perhaps the Church sees how weak Aristotle's argument really is.
The simple truth of the matter is this. You teach that the Holy Bible is wrong.
I never said the Bible was wrong.
If you say you are right, then you say the Holy Bible is wrong.
I believe the Bible teaches us how to get to heaven, not how the heavens were made.
Galileo had an interesting personal life. In 1600, he met Marina Gamba. Even though they never married, they had 3 children, 2 daughters named Virginia and Livia, and 1 son named Vincio. Galileo worried that his daughters would not marry, so he put them in a convent. Vincio, always selfish, was the cause of dissent in the family. He ended up being a musician.
Even though Galileo was under house arrest, he still continued his work. He is credited with making the first thermometer, even though it wasn't very accurate. Galileo also laid the foundation for the scientific method. In 1634, his study of forces and their effects on matter was translated into French. In 1635, copies of the dialogue concerning 2 chief world systems were published in Holland. He wrote 2 New Sciences, which is a summary of his life's work. In 1638, it was published in Holland. Around this time, Galileo became blind and ill. Towards the end of his life, Galileo said, "I have never met a man so ignorant that I couldn't learn something from him." In 1641, he developed this pendulum design for keeping time. On January 8, 1642, Galileo Galilei died of heart failure and a fever in Arcetri, Italy.
Galileo left a great legacy. He not only proved many of Aristotle's teachings wrong, but he also proved that the Church could be wrong. He discovered how the universe worked, and he will be remembered for it.
Galileo once said, "Count what is countable, measure what is measurable, and what is not measurable, make measurable."
In the new view which Galileo hurried to proclaim, the scientist's task was to describe the world objectively, as it really is, not subjectively, as it appears to be.
Their vain presumption of knowing all can take beginning solely from their never having known anything. For if one has but once experienced the perfect knowledge of one thing, and has truly tasted what it is to know, he shall perceive that of infinite other conclusions he understands not so much as one.
Nature is a book written in mathematical characters, he insisted, and anything that could not be framed in the language of equations was nothing but a name.
In my studies of astronomy and philosophy, I hold this opinion about the universe. The sun remains fixed in the center of the circle of heavenly bodies without changing its place, and the earth, turning upon itself, moves around the sun.
Aristotle had asked why. Why do rocks fall? Why do flames rise? Galileo asked how. How do rocks fall? Faster and faster forever, or just until they reach cruising speed? How fast are they traveling when they hit the ground? Galileo once said, "Two truths cannot contradict one another.